Today we are going to solve this problem. It's also a rating 1800 problem. As always, we are going to start from the examples here. So we are going to have two numbers in the first line. So the first number is the number in a array we are going to have. So we are going to construct this array, right? This is output. And in this array, it's going to be 7 numbers in the array. And um, this array has to satisfy 4 conditions. And there are 2 kinds of condition. Um, the one here indicates that this is the first kind of condition. That is, from index 1 to index 3, these 3 numbers should non-increasing order. So it can be like this. It can be like this, right? It's non-increasing, non-decreasing order, right? But it cannot be like this. So this guy is smaller than this guy. This is not allowed, right? It has to from this side, from this index to this index, it has to be non-decreasing, right? That is the first kind of condition. And this one tells us that from index 2, so from this index to index 5, 1, 2, 3, 4, 5. In this part should be non-decreasing, right? And so as this condition, so from 6 to 7, this part should be non-decreasing. And what about this kind of conditions? So it starts with 0. It says that in this part, so from 5 to 6, that is this part, in this part, there should be at least one number that is smaller than later numbers, right? It either can be like this, or let's say if if we change this number to 1 to 6, that is this part, then we can randomly choose 2 numbers and make one of them bigger and the later one smaller, so as to make this part is not non-decreasing, right? So that is it. So we have to find such a array that meets these 4 conditions. And if we can find such a array, we can output a yes and output any array that satisfies these 4 conditions. So if we cannot find such an array, we just output a no, right? Why cannot we find such an array for this test case? Let's give it a look, right? We have 4 numbers and 2 conditions. The first condition is that from index 1 to index 5, this part should be non-decreasing. And for this condition, from index 2 to index 3, this part should not be non-decreasing, right? So in that case, this guy is smaller than this guy. But in the first condition, this guy should be actually, for this condition, this guy should be bigger than this guy. But for the first condition, this guy is smaller than this guy. So they contradict each other. So we cannot find such an array. So how do we solve this problem? How do we find an array to satisfy all these conditions? So first step is to taking all of the first kind of conditions. So let's say we have a array, right? With 7 items, and we have three first kind of conditions here, here, and here, right? So we mark this parts of the array. So for this condition, it says that this guy should be bigger than this guy. So we mark this guy as 1. And they initially, all of them are 0, right? So 0 means that we don't know about this item. This item has no constriction. But if we mark it as 1, that means this item has to be bigger than the item before him, right? So for this condition, we mark this guy as 1 so that we know this item is bigger than this item. And we mark this guy as 1 as well so that we know that the index 3 is bigger than index 2. So after we mark these two guys as 1, we put this condition into our consideration, right? So we don't need to worry about this condition anymore. And as for this second condition, we mark index 3 as 1, right? It already marked as 1. So don't worry about it. So as we need to mark index 4 because this guy should be bigger than this guy, right? So that this part is non-decreasing. So we mark it as 1. Also, we mark index 5 as 1 as well. So for this guy, we mark 7 as 1 because 7 has to be bigger than 6, right? So we mark it as 1. So in this case, we find out that some of the items should be bigger than the item before it, right? So let's move on. So let's consider the second kind of conditions. So for this guy, we check from 5 to 6. There should be at least one item that is bigger than the later one, right? So the only thing we need to do is to, 1 second, actually this guy is 5, this guy is 6. So we only need to find is just one contradiction. In this case, we find out this guy has no constriction yet. So we can just make this guy smaller than this guy, right? So what constrictions do we have? So we have this guy should be bigger than this guy should be bigger than this guy because it's 1. This guy should be bigger than this guy because it's 1. This guy should be bigger than this guy because it's 1. So in the end, we find out that we have no contradictions about this guy. So we can just make it smaller than the number before it. So we just, after we set all these numbers to, some of these numbers to 1, and we starting to iterate through the second condition, we can just iterate from the left to right, right? So actually, we just need to check if for each second condition, can it hold? If it cannot hold, that means all of the um, values in a particular range are set to 1, right? So let's use this test case. So in this case, we have 4 numbers, right? And for the first condition, we set 3 numbers to 1. And for the second condition, we found out that for this guy, it has to be bigger than this guy because it is 1. So this condition cannot be met. So we output a no here. So if all of those second condition can meet, then we output a yes and iterate from left to right. So let's say the first number we just choose a random number like 5,000, right? And the second number, what should we choose? We can just increase this because the value is 1 here, so we increase this number by 1. So we get 1001 here. And because this value here is 1, so we increase again. So whenever we find a 1 here, we just increase the current value for the current index. And if we meet a 0 here, then we just decrease the current value. Like in this case, we got 5002, 5003, 5004, 5003, right? Because we find a value 0 here, so we decrease the current value and output it, right? So let's take a look at the source code. So here we go. So first we read N and M, right? And then we read all those conditions. So if we find the first condition, then we set all of those values to 1, right? And if we meet the second condition, then we save it into a array, right? And then we iterate the second kind of condition and check if each of them can meet, right? If one of them cannot be met, then we output a no, right? If all of them can meet, then we output a yes. And we starting to construct that output array. So if we find a value with 1, we increase the current value. If it is 0, we decrease the current value and output it, right? So that's it. That's it for today's problem. Hope that helps. All right. See you next time.